Alrighty, so SolidWorks sheet metal tutorial. This is an filament holder for my Ender 3 3D printer. For reference, took this picture. Um, is this showing up okay?
Yes.
Yeah.
Okay, so you can see it here. It's just a little bracket that bolts to the top of the printer and basically just holds the roll of filament. And this is the example one I did. That turns out to be pretty much the same, but took some measurements and yeah, so we'll go through the process of duplicating this. However, the um, basic fundamentals of sheet metal will be applicable to any part that you make, different bends, different geometries, all that stuff. It'd just be the same process. So there's many ways of doing sheet metal. My methods have changed over the past 5 years. I used to do it the hard way, and now I have learned an easier way. So we'll go through that in a second. That being said, all ways are valid. I have my own style of doing things. People have different styles you develop over time. SolidWorks is very free in that way, where you're able to customize things to your liking, and then if you produce good parts, it's all good. However, there are a certain set of standard practices that make editing parts easier, sharing parts easier, and if someone else wants to come look at your CAD, if they want to change something or they want to understand how you modeled it, if you follow some very simple principles, it'll make it a lot easier for yourself and everyone else around you. So we'll set up a new part. So I just have an imperial part. You can change your units down the bottom right corner here. So we'll do inch pound just because we are friends with the Americans. All right, so I'm going to do a sketch on the right plane. So we're going to right click on the right plane, make a new sketch. And then we're just going to do the basic side profile of our sheet metal part. So this is the new way that I've learned a while ago. So just make a rectangle and then a vertical rectangle. Oh, we got one more. Hey, Paul. We're just starting out. Feel free to follow along, or it's literally just made this sketch so far. So this is basically going to be the side profile of our main bracket. So doing this method of sheet metal, basically I want to make what is the base plate of the part that everything else is going to be bent off of. So, or whatever can get the most geometry in one sketch. So in this case, I'm doing the side profile. I'm just going to make the sides equal. I'm going to make that to 16 gauge, which is 0.0598. 0.0598 is 16 gauge sheet metal. If I don't memorize all of this stuff, I had to go look it up on Google when I was making this. Because I measured the actual thing and it was like 0.061, and because it was painted, it's a little bit thicker. Closest thing was 16 gauge. So now both of these are 16 gauge, and I'm just gonna trim up this sketch. I'm gonna go trim to closest is my favorite one. You can do power trim and trim away inside, but trim the closest is very consistent. And because I'm very anal about my CAD, I got an extra line here. It's not important. I could leave it. I'm just gonna delete that one, drag it over, connect it. So as I'm doing this, you'll notice that all of these lines are slowly going to start turning black. And that means they are fully defined. And a fully defined sketch is a happy sketch. I believe that's 0.8. And I believe that this is 6 inches. All right. That looks about right to me. All right. Everything is fully defined. And I am very bad at explaining sketches properly. So is everyone up to there fine? Probably make sure.
How did you do the is like equal for the thickness, the gauge
Yeah,
for both of
so
them?
yep. So I'm just doing a geometric constraint. So I'm clicking on one line and then holding control, clicking on the other line. And that will bring up this box of different options. It'll also be on the left side. If you like don't immediately click there, the box just kind of goes away. So oh, okay. So you got all of these different ones. I just made them equal. So they're equal length lines. Otherwise, you could just do another 0.0598 and on the top here. But if I wanted to change the thickness of this part, then I only have to change one dimension.
Okay, perfect. Thank you.
Yeah, so we got a fully defined sketch. Nothing can be changed. So I'm going to extrude that. So going to features, extrude bus base. And I'm going to make that, how wide is that thing again? Like 1.6. Let me just double check that. Like 1.45 for no reason. So a quick way of editing the thickness is you can just click on the part and you'll see all these dimension lines pop up. I can just click this, double click that. And that changed it, I think. Rebuild? Yeah, there we go. Yeah, rebuild button up here just basically makes sure everything's back to normal. All right, so we have our basic L. Hello, I'm sorry if I say your name wrong, Drew. We're just starting out. We've just made this L. If you want to catch up, awesome. If you just want to sit back and watch, that's cool too. We've got our basic L. And what is next is I'm just going to make the holes in the bracket. So something similar to this. So I'm just going to make a sketch on the front of this. Sketch on the front. I'm going to make, just first off, I'm just going to put a center line down the middle. Just for fun. And I'm going to put a circle in that center line of a dimension, we'll say 1.25 inches. Is that right? We'll say 1 inch. Not critical at all. So we got a circle that's bound to the center line. I obviously want to make it sure that it's fully defined. So I'm going to say that it is, say 3/4 of an inch from the top, which looks about right. I'm looking over to my left, looking at the actual part. So we got that one, and I'm going to do the little slot holes. So I'm going to use the slot tool. So there's many different slot options. I like to use the center point slot. I'm going to do one again on the center line. You notice like it kind of has this just lines going out. That's going to be your length of your slot. And you're going to click and then click again. Doesn't really matter how big it is. Because let me just double check these sizes. Yeah, 1/4 inch, of course. So sketch. I'm just going to dimension this real quick to 1/4 inch. And I'm going to dimension the length to be, say 2 point, yeah, we'll say 3 inches. Nice even number. And then, of course, it's still not fully defined. So I will do a dimension from the bottom here. So a trick for dimensioning from arcs is if you just hover over the arc, you'll see a center line dot pops up. And then if you click on that dot, you can actually dimension from the bottom. Otherwise, it'll make you dimension from the center of the arc. So I'll show you that real quick. So if I just click on this arc in the bottom, it'll go from the center, which is fine. But sometimes you want to know how much clearance you have or how much material is actually here. So you can hover and it'll pop up. And I'll make that, we'll say, 3/4 of an inch. Sure, why not? I think you can also select midpoint. No. Yeah, never mind. You just have to hover. Boop. And you can put a point there if you really want to have it. So I'm gonna make 2 more. Actually, I'm just make a little line first. Midpoint lines makes it easier. So I'm gonna do that. I'm gonna make that like 3/4 of an inch again. And then a quick way to make this into a construction line is if I just right click it and it's this symbol right here, construction geometry. Boom. Construction line. And then I'm just gonna match these up roughly. And then there's a new tool I learned of while making this. As if you control click all of the slots, you can do equal slot. It does all the dimensions for you already. All right. So how are we up to there? For those following along.
I'm doing good.
All right, I hear no protests, so we will continue onward. So I'm just gonna do a extrude cut through wall up to the next same thing. Just means that if I change the thickness of this, this sketch will be, or this cut will still go through the entire thing. All right. So we have our base flange. So real quick, I'm just gonna save this. I should have saved it more. Demo. So next thing I'm gonna do is we're gonna add our little side flanges. So these bend out, just to give it some more support, in the, like this direction, axial with the filament holder. That's a very common thing, just little like bracket, little gusset type thing. So again, I'm not even gonna touch the sheet metal tool. So I'm actually gonna like talk about sheet metal tools, what is available real quick. So this whole time I could have been working within the sheet metal tab, which I'm not too sure if is attached here by default. I think it is. I don't know if I've included it in myself, but if it's not, you can just like right click, go tabs, and go sheet metal. You can also turn off and on anything you like here. So these sheet metal tools are quite good, and that's how I started figuring out sheet metals on my own. Is often you will start with a base flange or a tab, kind of like this. So it would just be this face, this sketch, and this would be our base flange tab. And then everything else added onto that would be edge flanges, jogs, sketched bends, all of these additional things, which thankfully SolidWorks does a pretty good job explaining. And that's totally fine. The only issue with that is it can be difficult to make things accurate. So if, for instance, so there's gonna be a couple holes down here. If I wanted this distance to be exactly 5.1902, and I had like maybe another 2 bends in here. So if this was like all wonky, it would be really challenging to make that accurate. And you'll notice if you've done this in the past, if you use these and you wanted to make a whole bunch of very accurate features, that it would be very challenging, and like changing stuff is a huge pain. So starting with, yeah, So starting with just a straight up normal boss extrude, cut extrude, and then converting it into sheet metal is a lot easier than doing all of this stuff if you want stuff to be accurate. If you're just like, if it doesn't need to be accurate, you can totally do this. Totally fine. And I could do this for here, but I just do it for everything because it's yeah, it's just easier to be honest. So I'm gonna do the side flanges here, which is gonna be a little bit weird, but I'm just gonna start a sketch on the top. Gonna make some rectangles, and as before, I'm gonna control click these lines and make them equal. Gonna dimension that to be 0.0598, 16 gauge. And I'm gonna set these to be, we'll say 0.4 of an inch. And I'm gonna set these lines to be the same length as well. All right, so everything's defined. And then we are going to quickly extrude down to the bottom surface. So in the directions here, instead of going blind, I'm gonna go up to surface. And I'm gonna select the bottom surface here, then extrude all the way up to there. All right, so we've got what kind of looks like the bracket already. It is pretty much already there, but it's not sheet metal. So now is the step to turn it into sheet metal. So I've got all of our bends, got all of our pieces all ready to go. So I'm going to go to the sheet metal tab. I'm going to go to insert bends. And so in this side box. Yeah, no problem. Oh, he's already gone. But you can watch the video after it. Yeah, if anybody got to leave at any point, this is all recorded, so the video will be up on the YouTube channel. Yeah. So this bend parameters, you're basically selecting what face you want the part to be bent off of. And so for this, I think the main face is this guy, because basically this is gonna stay flat, this is gonna be bent up, this is gonna be bent up, and this is gonna be bent up. And basically everything is bent off of this main face. So I'm gonna click on this face. So we're gonna go down here. This is the bend radius. Good rule of thumb, bend radius is usually the same as the material thickness. So 0.0598 or 60 thou, basically the same thing. So we've got auto relief. I've checked that off. So basically in sheet metal, there's certain geometry that can't be bent, because right now as it is, this can't be bent. These corners are like not possible. And you'll see what will happen if we have, you can select any of these. I have ob round, no particular reason. So we'll try and do this and we'll see what happens. No bends found. Weird. But I know exactly why that happened. That was actually planned, by the way. We need to rip these corners, because right now it thinks that this is all of the same thing. This is all one face, and it's like, there's no bends here. What are you talking about? What are you on about? So I'm going to select this line and that line. And auto relief cuts are made for one or more bends, and you can see those appearing down here. And just like that, it's sheet metal. This is pretty much done. It is done. The rest of the stuff here is just the fancying stuff up, trimming corners, and I'll show you that in a second. But you'll see that this is a sheet metal part. All the bends are there. It's got the bend radius, and I didn't have to do any of this miter, flange, jog, all this other stuff, which tends to be rather annoying. So I'll show you what appeared here, because we were right here, and we got all this extra stuff just popped up. So get the sheet metal. Just turn this into a sheet metal part. It ripped these corners down here. So I probably could have set this to be the same height as this, probably lead to be the same thing, but there's a little tiny extra relief here, which probably would not even show up in manufacturing, maybe. But it just adds some extra bend relief. It made the flat pattern, and then it sort of flattened the bends and it processed the bends. It's kind of strange that it did that reverse, but I don't question the computer. So you got everything here, and this is the flat pattern, which can be used to add stuff on, but it actually is for making drawings. So if I unsuppress the flat pattern, you notice that this is what the pattern would look like if this was plasma cut, water jet, laser jet out of, or laser cut out of any material. So this is the face that you would basically turn into an SVG or whatever, to be water jet. So we can suppress and unsuppress that to get back to our sheet metal part. So the only other things I'm going to add on to this is I'm going to round these corners off because they are sharp, and sheet metal is very sharp. So sheet metal does have a corners tool. It's got corner relief, break corner, corner trim, but if I do that on this one, it's going to trim this bottom corner as well, and I want to save that one. So I'm just going to go back to regular old fillet. I'm going to change that to 50 thou is usually the minimum size for a fillet where sharp corners don't become sharp anymore. And that's like 50 thou is usually a good number. It's basically as small as you want to go for any sort of fillet. Any smaller, it's not really going to make a difference. So doing 50 thou on 1, 2, 3, 4. And good rule of thumb is to try and do your fillets last in any geometry. So have them at the bottom of your feature tree. Just makes editing things easier, changing parts. If you kind of have them intermittently, you notice that when you try and edit stuff or add on new features, SolidWorks can get annoyed for like large components. And I'm gonna do an extra thing here, which is on the actual part. You'll notice that I can't really see, but this bottom is welded here. This is how they actually add in that extra structure. So for fun, even though this is totally unnecessary, but I'm gonna do a corner weld. I'm just gonna click in there. Easy. Boom. I'm gonna do it the other side. I don't think you can do both at the same time. You know, do one face at a time. Yeah, to weld this weld symbol. Look at that. Already adds it in there for us. So weld symbols are a rabbit hole of drawings that you can get into, and probably late in your professional career, if you're doing for a big company or something like that, you will need to know. I mean, pretty straightforward. Just Google it. I've had to Google it a few times for making drawings for some of my co-ops. This symbol is basically just means a fillet weld. Fillet weld on the outside, fillet weld on the inside. This is the radius of the fillet, or the radius of the weld. And if there's a number on this side, then it would be the length of the weld. So basically how long the weld is. That's the basics. I actually don't know what this dotted line is. I actually do not know, but Google would probably tell me. All right. So yeah, that's done. I forgot to check in. How are we doing up to there?
I was wondering, how do you do that 3 symmetrical slots?
Yeah, for sure. So we'll jump back. So in this sketch, basically, I just did a what is this? A midpoint line from the middle of here just to 3/4 of an inch, and then I made 2 more just like random slots on the outside of just like any length, and then you can control click just like you would for any geometry, and it is equal slots, and that is equal length and equal width for the slot.
Okay, thanks.
Awesome. Okay. Yeah, so that is the very basic steps for making any sheet metal part. You can follow the same steps to make pretty much anything. You may need to delve into what is the all of these extra edge flanges and stuff if need be, but it's pretty self-explanatory for the most part. It would take some messing around. You'll see there's lots of extra tools and yeah, lots of extra features that SolidWorks has. Even they're still adding to it, so it's always good. Yeah, so we got our finished part. I'm gonna make it black just for fun. And I'm gonna make it powder coat to black. Yeah, so general SolidWorks wisdom is when you're modeling a part, if you're reverse engineering a part, I like to model it as it were made and as it will be finished. So everything here is exactly oh, I totally forgot. I gotta put holes on here. Can't even mount it. That's fine. So I'm gonna go back to here. So using this little bottom thing is nice for rolling your parts back. So I'm just gonna do hole wizard real quick. I feel like I'm forgetting a step. So I'm just gonna make a clearance hole. So using hole wizard clearance hole, screw clearances, anti-inch. Do M10 or like a 1032, just normal size. We'll go through all. And then positions. Some people like to do the sketches outside of the hole wizard. I like to do it inside, just so that the feature tree is cleaner. So I'm just gonna make a center line here, and then another line just randomly. And then same as before, I'm gonna wait for it. So this one you can actually go select midpoint, but you can wait, it'll pop up. Control click, make those coincident. So now we get a midpoint line. I'm not too sure why in Hole Wizard it doesn't allow you to make midpoint lines for some reason, because it's just not there. It's just strange. And so the way you make holes in Hole Wizard is you need to add points. So point here and point there. Set that to be classic 3/4 of an inch. And we'll say 0.3. A good rule of thumb for distance from holes away from edges is I think it's a diameter and a half is like extra safe. I actually don't remember I think it's like, how big are these holes? 0.2. Yeah, so 0.3 I actually just guessed. That's a good guess. So 0.2 is the diameter, so diameter and a half, 0.3. All right, so we got our clearance holes there. Roll that back. All right, now we're actually done. Okay. So yeah, I mean, it is tempting, as you noticed, to just put the clearance holes right at the bottom here, but make sure that it's in the base part. Then you are certain that those holes are going to be exactly in the same relationship position wise to this hole, all of these features are going to be the exact same. Nothing's going to change. Okay. So I'll go real quick over making sheet metal drawings. Sheet metal drawings is a tough thing because every shop, every machinist, every fabricator likes different formats. So, oh, I don't even have the I don't have the standard format uploaded, but not a big deal. So, but there are some fundamentals that if you include, you'll generally make people happy. So did I copy that? So I'm just gonna add in the sheet format because the basic one is gross. While this is loading, does anyone have any questions? Okay. Alrighty, so I'm gonna add in a model view. And I got my filament holder demo. Go next. And then I'm gonna select the flat pattern. And then as we hover over here, click, there it is. And I'm just gonna rotate this 90 degrees. Please. Never mind. Oh, there it goes. Just so it's more evenly spaced on the page. And I'm just gonna change the scale to be like 2:3. A little bit bigger. Do I want it this way? Which way makes sense? This is the finicky part. Let me just check. Which way did I have it before? Yeah, I had it this way. All right, so now that we've selected a flat pattern, you notice a lot of stuff is automatically generated. So it has bend lines, it has the bend radius, and the bend degrees already included on the part. They're not in the best positions, but, and so this is a totally a personal preference thing, is like these drawings. But one things you do need to have is these are the bend lines. You do need to have dimensions from the bend lines to a feature that is a measurable and like or important. So if you had like a center line that was like easily measurable from, if you had a very critical dimension, this is where you would put it from. So these are pretty easily measurable. If you measure like, okay, 0.35 from the edge, that's where your bend line's going to be. And do the bottom as well. So you've got our 3 bend lines. You could just say tip here, but not super critical. Let me think. If you ever have these blue coordinate system things, the way to turn them off is here. So that's in here, this guy. Okay, and I'm not on my drawing standard. So I made a drafting standard. There it is. That's located in the templates. It's basically just a bunch of preferences that I like, and I'll have to remake these. Over the years, just stuff that I like. not that. So some more stuff that you need in every actually I don't say that because some we've gotten yelled at before, but I always include overall dimensions. So this is basically how big the piece of metal needs to be for it to get water jet or plasma cut. So these are the overall dimensions. For some reason, I think it was GA didn't want that, which is confusing to me, but yeah, it basically comes down to at the end of the day, talk with the machinist or shop that it's going to be made at, because they will all want different things. Some people, this at Northwest Fab was good enough. This was good enough for sheet metal drawing. Some people, oh, so I'm going to put some liters on here because it might get confusing. Liters are always good. Although these are not in my drawing standard format. Meh. Yeah. So you got the bend lines, dimension bend lines. You've got the radius, the angle, which direction. But one thing I also always like to include is I'm going to add a new model view. And it will just do like the side. Yeah, we'll do a side. And then we'll do make that a little bit bigger. I will do a projected view. Is I will always add in basically what the finalized part looks like, and also an isometric view. Oh, it looks very dark. It doesn't show up super nicely, so I'm just gonna change this to be a little less dark. Be like gray. So the reason I put this as a shaded part is this shows that it is gray. It has been painted. Do I have it like that? Yeah. So another one I will say, if the part is being post-processed at all, so heat treated, painted, powder coated, I will always put a note that says powder coat black in the top left corner somewhere on the drawing. That just shows it is being post-processed. And I usually will make this a little bit smaller. Doesn't need to be very big. Put that in the top right corner. Okay, so we've got our ones here. So I will add in bend angles. Ezra was right and said that most fabricators will bend off what is called the complementary bend angle. And if it's like some wonky number, like some crazy like 32.5 degree angle, I will add in both sides. Basically, anytime you can avoid a machinist or a fabricator doing math, they will thank you, because otherwise they will yell at you. Ask me how I know. So I will do the same thing. So it's pretty self-explanatory that these are the same angle. As you can see, it's also labeled there. This is redundant, but different different people like to work off different things. There we go. Not super nice. So this is actually where one trick I like to do is, this isn't very useful how big this is. So I'm just gonna do a break view. Yeah. Utilize those at your discretion. Just save space on the drawing. And this is small? No, that's the right size. I can even make this a little bit bigger. Even make that 1 to 1. See, I made it. The breakthrough saved some space. Oops. And able to make this a little bit bigger. Okay, so we have our actual angle and our complementary angle. And we have our overall dimensions. We have, so one thing for cost report that we do specifically for FSAE is we do have to do water jet length. So I think one way to do that is in the flat pattern. If I make a sketch and convert entities, is it Ezra, can you tell me if it is the outline or if it's all um length of like all of these features? If you remember at all either. If he's still here. Anyways, so I just made a sketch on this flat pattern. You select all, and if so, I have a hotkey for the measure feature, which is evaluate measure. The total line length is here. And so we will add in like water jet length 18.3. So I think for the cost report, I would have to convert these inner ones as well. So just like, which is kind of unfortunate because you can't really select these nicely. One thing I will mention, so this is this is a hot tip. Measure 43.1. So I'd be like, so you'll see in some of the drawings, water jet length. That was also one of the ones we added in and sent to GA, and they're like, why is this in here? It's like, it's not for you, it's for us. So I added this in a note, total water jet length 43.1 inches. I'm just gonna delete that sketch too. So for like cost report, 40.1 water jet. Make that a little bit smaller. Oh no. Oh, I forgot to. So if this happens, this is just because the part is in flat pattern mode. There we go. So one thing you can add on, not really necessary for most use cases, is weld symbols. Because it's just a mess. It's just a lot. But just because we can. Just to indicate that this is welded. And that it is, so I'll also add a note. Note. Rounded after welding. So notes are your friend. Thanks, Paul. This is pretty much the end. So we got a little weld in here, rounded after welding. We'll say ×2. Sometimes you might want to make another separate drawing just for welding if there's like a ton of complicated welds. So stuff like this is more so for industry, not necessarily required for just like normal drawings. Some companies like won't ever use these. Some will. But that is a tool. And as I said before, just Google weld symbols because they're super complicated. And just there's a lot. Okay. So let me go over everything I get. So because it's being water jet, I don't usually call out dimensions. So of like these features, unless they need to be finished afterwards. So if this diameter was like a super critical dimension, which you should never have supercritical dimensions in water jet parts, you would basically make a separate display state in Solidworks. All right, see you, Aaron. Separate display state in Solidworks where this is like a certain amount smaller, either to be reamed or milled post-processing, which is a lot of extra steps. So if you can get away with having the final dimensions being what the water jet dimensions are, then do that. That being said, there are scenarios where this would have to be, for instance, if this was a little bit smaller, or actually, I can just do that here. Reamed. And you would know that this has to be post-processed after water jetting. Or after everything is assembled, but at some point before it is complete, that needs to be reamed. All right, that was a lot. But anyone left? Freddie, you have any questions?
No, I don't. It was great. Thank you for that.
Awesome. So I will end the recording here, and yeah, if anybody has any questions, always shoot me a message on Discord. Hopefully this was comprehensive enough.